Hi, let's understand about greedy algorithm. A greedy. Okay. So what does it say? A greedy algorithm is an approach for solving problem by selecting the best option available at the moment. What you do in greedy algorithm is like when you are finding the solution along the way you just starting build the solution at every step you decide that what is the best option I have. Should I include this, should I exclude this, or should I do something with this value? But you don't know about future values, you don't know what will come later, you don't know about all those. But every step you select the best option available for your problem in greedy algorithm. It doesn't worry whether current based result will bring overall optimal result or not. That means it will select a result which is optimal for current solution, current problem, current small problem. Okay. It doesn't know that after solving the whole problem, will it be optimal or not. The algorithm never reverses the earlier decision if it is wrong choice, and it works in top-down approach. Let me explain the definition with the help of an example. Let's say an example question. You are given a array in sorted order 1, 2, 3, 5, 9, 10, and 11. Now, someone asks you to select four elements from array such that sum is minimum. Sum is minimum. How will you find out it? Now you will come here, you know that array is in already sorted order, so you come here, you have one. What you will do, you will include this element because you want to minimize the sum, so you will take the elements with lower value. So when you come at 1, you will in your answer you will include 1. Then you go to 2 and you will include 2. Then you go to 3 and you include 3. You go to 5, you include 5. Now you go to 9, you are exhausted of your number of element, that is that threshold, and you will exclude this. You will not take this, you will not take this. This will be your answer. Now what you are doing, now compare your algorithm with this definition. In this approach, by selecting the best option available at that moment, when you are here, you are thinking that your best option is to include this, because this itself is a very small number, smaller number than those we have later. We are come that numbers are coming later. From that, it is our smaller number. So this is our best option to include this at this moment. It doesn't worry whether the current best result will bring overall optimal result or not. You doesn't care about that what the other elements give in sum, isn't it? You are asked to find minimum answer, minimum sum. So you are starting from first element and like going to the kth element, and like 4 here it is specified with 4, and that phone number of element, and you doesn't care that is there any more combination of number which gives lesser number, which gives lesser sum. So because you know that the smaller element will make more least sum. Okay, so it doesn't worry, but here in this question, we get our answer to be optimal for the whole problem also. We got the right answer, but always it may not be true. For an example of this, like always applying greedy may not be true, like 0 1 knapsack problem. We will do it later in the dynamic programming. So um, the algorithm never reverses the earlier decision even if the choice is wrong. Okay, so you are selecting 2, you are selecting 5. Now at this point, if you realize that you should not select 3, you cannot do anything. Like you have selected this, so you have to go on. Okay. Otherwise, this will be like you can do it. You can come and change 3, but this will not be a greedy algorithm in that case. Okay. This is somewhere comes to backtracking. So, and it works a top-down approach, obviously. So let's go through some of the interesting questions we have in greedy algorithm. The first question we have, that is, let's solve um, okay. So let's solve the question fractional knapsack. What the question says, you are given with weights and values of n items. You have n items. We need to put this item in a knapsack or a bucket of capacity W. The total capacity is W. To get maximum total value in the knapsack, unlike 01 knapsack, forget about this statement, you have to get maximum total value of a knapsack, and you are allowed to break the item. What does it say? Let's take this example and understand. So n equals to 3, W equals to 50, values is values are 60, 100, 120. 60, 100, 120. Weight is 10, 20, 30. So these are 3 items. 10, 20, 30. Okay. So what you have to do, you have to maximize your values, or you can say profit, whatever value. You have to maximize your values, and you have to include this item in your box such that you fill your knapsack box. Okay. So let's say we are just now taking some values, like let's take the first, include the first element, first item. So what will happen, your weight will be currently 50 minus 10, and values will be, you already got 60 value. Okay. Now why minus 10? Because you are filled with 10 weight. Now you have left with 40 weight. Now include this also, 20, and you will have values of these also, that is 160, 100. Total how many values, how much values we get? 150. How much weight we have left with? 20. Okay. Now the third item, consider the third item has weight 30, but values is 120, whatever, but weight is 30, so we cannot include this item in our knapsack because we have weight left with 20. So what we can do, we can break this item. So let's break third item. Now we have 30 and we want 20. So how do we calculate? Uh, so we want 20 out of 30. Okay. So 30 was giving profit of 120, which is values of 120. So how much 20 will give? Normal calculation. So that is 3, 4, 8. 80 will be value we will be getting if we include 20 weight of this item. So let's make weight as 0 because we have included 20 from third item, and plus 80 we will get value. So how much is final value we get? It is 240. What is the answer? 240. Okay. But one thing that I have to note, now we have included one by one item, but this will not be the case actually, because you have to be greedy. That's what question says. That what the problem says. Like, yes. So to be greedy, what you can do, like, you you don't have to select the items one by one. Select the item with maximum values per weight. Select only those items which are giving you maximum value per weight. That is, if you look at this is giving you value 60 instead of taking your weight of 10. So values to weight ratio is 6. That means it will give value of 1 for your one weight. Okay. So, and here if you see 100 by 25, it will, second item will give you value of 5, and third item will give you the value of 4 per weight. So what you will do? So you want to be greedy, so you will choose the item which is giving you highest values per weight. For this question, 60 by 10, that is 6, and after that 5. That's why you are getting right answer, because it was sorted in that order, but it may not be. If you first include 30 and then go to 20, then you may get wrong answer. Okay. So what you have to do? You have to first sort the array. So first you have to sort the array based on not only values, isn't it? Not only values, that is values upon weight, because you have to find out values per weight, what is the profit rate. Now the second, you have to pick items one by one. That is all about the question. So let's write our code. So first we will sort our array. So let's sort it. Array plus n with a function. Say item A you have got. Just a minute. And item B you have got. Just take the reference variable, so it will be faster in execution. Now we have to return is A's profit is bigger than B's profit or not. So how you will get that A's profit? A's profit is A's value per weight. So A dot value, and let's convert it into float, or let's double, divided by A dot weight. Okay. this profit is greater than this profit or not. So again you can convert this to double b value by b weight. Now you have you have done your sorting. Now you have to first you have to calculate the maximum value. Maximum value you can get by selecting one by one element. So for int I equals to 0, I less than n, I plus plus, and okay, if left weight, the weight of your knapsack, if it is greater than the current item's weight, so current item's weight is lesser than your total bag, that means you can totally include this item in your value. So in your knapsack, you just include this item in your knapsack, and after that you can reduce your knapsack space by this weight because you have included this item. Now consider the case when current element weight will not be W. Okay, in that case what will happen, like the current item weight is more than W. In that case we will include some portion of this item. So max value, okay, this is not going to be in, this is going to be double value plus equals to, now consider this formula. Sorry. Yes, so the weight of current item is 30, but you are left with space 20, so that is 20 by 30. So current space you have is W. It's converted into double for the point division, and I current item weight is ARR of I of weight. Now this is the fraction, and you have to multiply the fraction with the current item profit. It is value, current item value. It will give you the value you will include, and obviously you will not have any space, so you can initialize W equals to 0. If you don't, then also no problem, and break out of the loop, and we can return our max value. Okay, so this is giving right answer. Let's submit it. Okay, so there is no problem, and we have successfully solved this question. And this is a greedy question where you are selecting the item first which is having more value, which is giving you more value per weight. Okay, so that's all for this class. Thank you.